All right. So get your paper plate and flatten that sucker as much as you can. Make sure you have your notes out and have that circle lab out because we're going to go through those. So your notes and the circle lab. Okay? You flatten that out. Other thing that we need is if you didn't get a circle, pick up a paper circle. This is the second part of the lab that you have. That was me. Sorry. Yeah, Miss Munson, they're different sizes. Somebody said that yesterday. I go, yeah, cut back on the cheaters. If you know me, I'm that teacher. Like, legit. Got your stuff, got your notes. Let me pass this around. There you go. Most of your teachers are going to have a paper sign in for you. So Ms. Moore has it right now. She's going to find her name on this column, the second column. It says Wednesday the 20th. So she's going to find her name and she's going to sign it and then just pass it back. Either teachers are going to have it, pass it around, or they're going to have it somewhere in the front for you to sign it. So you're going to sign in for attendance. Okay, it makes it a little bit easier. That way we have a paper copy and we can always go back to that paper copy if needed. All right, so notes and your lab. Like I said, I'm probably not going to be able to go through homework number 1 today, but I'll explain what I'm going to do with homework number 1 for everybody. Still going to be due this Friday. Okay. Ready is what I need. So in your notes on page 1, I didn't do page 1. I left it blank in page 2 and part of page 3, I think it was, because I wanted to go over it in person with you. So you should have already watched the video and did the other notes though, because I mean, there was more notes to do, right? And hopefully all of the other notes are completed. Now on your notes that look like this, page 1, we did part of it at the top already, and we're talking about circular motion. So let me go back and explain to you, why are we even doing this? I understand, Ms. Munson, I don't, I'm only taking physics because I have to, not because I want to be an astrophysicist. And I apologize about the color. It's been pretty ugly yesterday. I'll contact them about this. Remember last semester we talked about objects moving, and we talked about one-dimensional and two-dimensional motion, right? One dimension is like going forward or back or side to side, but imagine it in a straight line. Two-dimensional was going up and down and side to side, and we were able to form right angles, and we were doing SOHCAHTOA for that, right? Now, things don't just move sideways, slanted, or just straight up and down. Things also move in a curve, parabolas, or in ellipticals, or in circles. So circles are the easier one to deal with first before you get to ellipticals and pre-cal and other stuff, okay? So the notes here are going to be amazing later on this unit when you take your pre-cal or calculus or something else, okay? This is good notes. So if I asked you or told you, imagine this lizard that's on the floor, and the lizard, it crawled, okay, it waddled or whatever, about 3 feet. About 3 feet. Now, if I said about 3 feet, you could probably visualize in your mind, without having a ruler in front of you, that's about 1 foot, 2 foot, about 3 feet. So the lizard probably traveled about so far, right? Now what if, because in physics we use different words for circles, right? What if the lizard traveled 22.6 radians or 22.6 rads. Okay, and some of us be like, well, what do you mean? What's a 22.6 rads or radians? Well, that's the words that we use in physics, okay? So that's what we're going to talk about today, because I need to explain to you in your mind, because I'm such a visual person, and I think most students are too, that I want you to be able to visually see that when I say 22 rads, your mind is already thinking, okay, there's the circle, da, 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 and this is how far the lizard traveled. So I'll go back to that in just a moment once we finish it. Because in your notes, the word circumference is not a new word for you. You know that word. The definition is pretty much like the perimeter, a simple definition of a circle, right? Or the outside of that circle, the circumference. Now, what about the word radian? And I know, I'm sure everybody's already had Algebra 1 from high school. You've already had geometry. Some of you probably already took Algebra 2. You might be taking some kind of pre-cal or something right now, or in Algebra 2. But what about radian? Because you've had a unit over circles before the past, right? Remember 2 pi r? What about that word? What about circles do you know? 2 pi r, circumference. What about this? Radius. That's a word that you know, right? Pi is a number you've told memorize. But what about radian? And that's a word that most of us have not been taught before. And I need us to understand that word. Now, the shortcut for the word radian is called a rad. Okay? So a radian or a rad are the same thing. So that's what we need to understand, because that's how we talk about distance regarding a circle. Okay? So let's go back, or we're moving to your lab now. And I'm going to flip back and forth to the notes in the lab paper. I'm listening. Oh, the sign in. Thank you. Miss Gabby, right?
No,
Where's Gabby? You're right. Gabby's number 4. Okay. I know Kennedy. I know Vega. Okay. I know Cameron. I know Austin. Miss Moore. Aiden, who's going to sit in seat number 1 from now on. No, not right now. Got you in my head now. Wait a minute. Anahi? Ayana. Okay. All right. I'm gonna do better. Normally I do better, but heck, we've been on computer, you know, and some of y'all's little pictures that are like this small. I mean, my eyes aren't that good. I'm getting old. So let's look at the lab now. It says go ahead and get your paper plate and let's flatten it out, which we did. But we're gonna go ahead and fold it in half, and then we're gonna fold it in half again, and we're gonna make it into quarters. So let's do that. Now, the better you fold it, the more precise you are, the more accurate you're gonna be with your measurements. So you're gonna get that sucker and you're gonna make sure it's as exact as possible. Miss Moore, you're gonna like this unit. You're gonna be like, man, my teacher in Friendswood, right? Friendswood never taught me this. You go back and you taught them. You taught everybody in Friendswood that they should be taking this. Yeah, but you're gonna like this though. Do you know what the word radian means? Oh!
Wait, you're from Friendswood? What grade are you in?
I'm a junior.
I'm a junior too. I've seen you around. I think you were in the last year. Oh yeah, Spanish. Sorry. This is.
See, look at that. Same school, and we're not even. But now y'all got a new bond. Okay, this collegiate, because it's a little tough here. You know, you need each other. Believe it or not, you need each other in this school because it's tough. So once you do that, here's what I do. I go ahead and open it up, and since it has a crease, it says in your lab paper you're going to get black. I don't know. Use if you have blue pen or pencil. Go ahead and just kind of open it up, and on that crease, draw a line. Okay. Now I'm going to use that line as a reference. Okay. And I'm going to fold it again because I need to make it into quarters. So go ahead and make that line. And then open it up. Did you do this one then? Did you do this?
I never did that. But we had a circle and we wrote around the.
You did the unit circle.
Yeah.
Okay, so this is a unit circle, but in physics version.
Right, we're doing it with
Yeah, we're not doing pre-calc version or calculus version, because they do fractions. All right, so now that you got it, open it up, fold it again, but I'm gonna have my two little lines touch. And I want this to be exactly in half. Crease it again, make your line, so that way it's broken into 4 equal parts. Okay? Go. There we go. And let's break it into 4 equal parts. So get your pen or pencil. There we go. And we got 4 equal parts. That was number 1, and I'm just going to mark that off because we did step 1 of your notes. Number 2, using a ruler, draw the line segments along the fold in black, which we did. Label the edges of a circle. So if you kind of maybe had a chance to talk about unit circles already, this is really similar to that, but it's going to be physics version of it. And it says, go ahead and write in 0, 90, 180, 270, and 360. Now, when you're doing that on a circle, you actually always start on the right side at 0 degrees. And then you move counterclockwise to 90, 180, 270, 360. Okay? So let's go ahead and put our degrees in. I don't know why it's so bad. Now it says here, let's mark off number 2. The folding process located the center of your circle. Yes, it did. Get a piece of string to measure the radius of this circle. Right? Isn't the radius from the center to the edge? So get that piece of string and measure that distance. Cut the string the length of your radius. Cut the string the length of your radius. Now, the number 1 mistake that students do is that they get that string and then they stretch it out. And don't do that, because what's going to happen, it's going to recoil back. So just kind of find that string and cut exactly to the end of it. And it says on your lab paper on number 3, now use your ruler to measure that length of your string. What is the radius? Now we have a ruler, so we can do in centimeters, but it says here, convert it to meters. Why does it say convert to meters? It's not just to be ugly and make you do conversions. It's because, remember, in physics, all math equations for distance has to be in meters. So go ahead and measure that with your ruler, which you have. All right, we all should have rulers. If you don't, I have extras. Remember, I bring tons of extra supply just in case if you need them. So grab one if you need one. And measure that and put that number right here, and let's convert it. I'm going to do my King Henry drinks utterly delicious chocolate milk. Aiden, what do you have for your distance? When you have it, you give it to me. Y'all don't cheat off of that. And don't forget, we never use inches. Those are bad. We're not carpenters. We're inside the box.
Yeah, 12 centimeters.
12? Is it 12 exactly?
Well, it's more like 11.8.
I like your 11.8 better. I don't know what yours is, but I like 11.8 because rarely do we ever get exactly at 12. I would rather go with 11.8. Now let's convert that. Remember, this is centimeters, and here's centi. We're converting it to meters, which is at the base unit. So that means that we're going to have to move our decimal 1, 2 places to the left. So 11.8, let's move that decimal 1, 2. The new number is 0.118 meters. And so that's the reason why it's there. Just kind of, let's get our brain back into remembering how do I do conversions, okay? And don't forget all math equations in physics for distance are in meters. So we did number 3.
This one said, do you have extra lab papers? If not, I can just do it on a piece of notebook paper and write it down here.
Can I give you this one?
Oh, sure.
There you go. That's all yours now. Now, I don't have another blank one, but I have the one that I did yesterday, and I'm gonna just cover it up, okay? So that way we don't just see everything, if that makes sense to us. So this is what yesterday they got 11.6. We got 11.8, you got whatever. If you have a different number, use yours. If you don't wanna cheat off of Aiden, I'm gonna cheat off of him because I think he's a reliable source. Let's keep going. Number 4 though. Number 4 says hold one end of that radius string that you have at the 0 and wrap it around the edge of the circle plate and make a red mark in red. So here's my plate, here's my string. Start off at the 0, which is right here, and don't stretch the string. Make it wrap around the edge of the plate. The more exact and precise you are, the better your measurements are gonna be. And right there at the end, where it ends, get your red. It's almost like a 2-person project. And mark it in red. And that was we're on step 4. We're on step 4. So now that you did that, it says go ahead now and go from the center of your circle all the way to the point that you just made and use something, and I'm going to use my ruler to make a straight line. Okay, from the center of your plate all the way over. I'm going to use the ruler, or you can use your protractor or whatever, and make a straight line from the center. There. So I made a piece of the pie, right? And for me, a piece of pizza. I mean, I don't know. I'm more of a pizza person. So I made a slice of pizza here on my cake, or on my, it's not a cake, I was gonna say slice of cake. Slice of pizza on my paper plate. And it says here in red, label it radian number 1. That is a radian. A slice of the pie, a piece of pizza, out of the whole thing, this one section is 1 radian. Okay? Just like if I got the ruler and I said this is 1 foot. Kind of makes sense hopefully now? This little piece, but wait a minute. When we use a ruler, the distance from here to here is 1 foot. On my paper plate, the distance from 0 around the edge is 1 radian. Now let's keep going. Mark off number 4, let's go to 5. Use your protractor and find the degrees. Find the theta. Look right here. From here to here, what is that theta in degrees? We'll use your protractor to find that. Now, we all have different protractors. I have this one right here. It has a little dot in the center. That dot in the center needs to go in my center here. This little line that's here on my protractor needs to match up on this line right here. My 90 degrees and this line right here, the number 3, needs to match up on my 90 degrees. So let's match it up. There we go. There we go. And let's see, I got about 123, right? About 1, is that what's going on? You don't like it more?
Isn't it supposed to start from the zero over instead of 180.
I agree with you, so what is that? It's not 123.
Somewhere around there?
What's a,
Or I don't have that exact.
oh, you don't have, like, your protractor's different?
No.
No, we don't
I
have the same.
We don't know.
Oh, your angle, your theta because of my line. Oh, gotcha. So I started from over here and I went all the way up and it says 123. It's not 123, absolutely at all. Obviously, if this is 0 and this is 90, it's less than 90, right? So let's go ahead and Cameron said, and Ms. Moore said, this is 0. Use these numbers at the bottom this month, and it says 10, 20, 30, 40, 50, 60. So it's between 55. So if this line is 55, that's 56, 57. So I got 57 degrees, personally. I'm not sure what you got, but that's what I got. Now, on your lab paper, though, it says, go ahead and write down your degrees. I got 57 degrees is what I just got. Now, number 6 says, go ahead and let's continue with your string. Pick it up again. Start at where you ended up at and rotate the string around the paper plate and make another piece of this pie. So all the way around, all the way around. All the way around. With your red, go ahead and mark it where that piece of string ended at. Go back and do the same thing. Get your ruler, connect that point to the center of your paper plate. And it says here on number 6, in red, label it radian number 2. So radian number 2. So if I told you that the lizard traveled 2 rads, or the lizard traveled 2 radians, that means that the lizard started here, and it traveled to this distance around a circle. Hopefully now it's making sense. Because if I said that my object or my lizard traveled 2 feet, it went 2 feet. But if it traveled 2 rads in physics, that means that here it passed 1 rad and it went 2 rads. Now it says here, go ahead now on number 7, get your protractor and find the degrees of this theta. So I'm gonna go ahead and put a little line, a little curve, and I'm looking for this theta right here. Come over here, line up the line and the little dot, line up your 90 degrees. And let's see, I'm at about, that's 123, and this is 768. So I need to find the difference between those numbers, right?
Let me just put it in retro right here.
You're more than welcome to. Absolutely. If that works. So, if I need to, I like to find the difference. That's how I like to do it. So for me, if I'm at 123 and this is 68, the difference is subtraction. So I'm gonna type in 123 on my calculator and I'm gonna subtract 68 and I'm gonna find my theta. That's how I do it. Is there more than one way to skin this cat? Absolutely. So if you like to find your theta a different way, you're more than welcome to. But for me personally, that's how I do it. I find the difference. So, give it to me, Ms. Moore.
I have another question.
Yes.
Wouldn't it be the same degree though, if you were basically using a meridian?
Whoa. Ms. Moore, hold on, 58, oh, 68. Let me, because my brain, Okay, what kind of blasphemy over here are you speaking?
Sorry, I got the same degree, as I was measuring it out. So if you have the string and you're measuring it the same length over, then basically it will be the same 57 degrees.
Duh, hello? Most of us don't click on that one. Here we go, let me say out loud what she said, and I like what she said, absolutely correct. She said, Miss Munson, why are you doing that? She said, if I started at 0 with this piece of string, and I worked my way around, which so happened to be 57 degrees, and then you told me, go right here at that red line, do it again, and she said, I did, all the way around. It's the same string, she said. Wouldn't I just be 57 degrees again? Absolutely. That's what it should be. But is it? No, because we're human and we make mistakes. But I made it, mine is really, really small. But absolutely. It should be. That's theoretical. But does it come out theoretically exactly the same? No, because we're human. So let me come over here, and I just noticed that I didn't go far enough. That's my line, I screwed up. So go ahead and find your theta, even though it may not be exactly 57 degrees, if that makes sense, Ms. Moore. I want everybody to find their theta. Okay? So personally, I'm gonna find it right now, but it probably is not 57 degrees for me. It's probably gonna be something else because I'm human. But it should theoretically come out. So 123 and 65. So 123 minus 65. So I got 58 degrees here. Should it be 57? It should. Theoretically. Does it come out like that? It doesn't. What do you want, Ms. Munson? I don't want you to take the shortcut and say 57, 57, 57, 57. I want you to actually do the measurements and find out. If it's 57, put 57. If it's 58, put 58. If it's 60, put 60. Okay? I don't want you to sit here and theoretically, you know what it should be, but mathematically it doesn't come out like that because we're human. Okay? So let's do it again though. Whoa. Write it down. So my second one, I got 58 degrees. Put it down on your lab paper. Number 8, do it again. Use that piece of string and make a third piece of the pie. Okay? So I'm going to come over here and I'm going to do it one more time. Wrap it around the edge. Mark it in red. Connect those lines from the center to the edge. Connect it. On your lab paper, on step number 8, it says call it radian number 3 in red. Now I made 3 pieces of that, 3 pieces of pie. Now on step number 9, use your protractor. Go ahead. I'm at 66 and 9. So find the difference, 66 minus 9. I got 57 degrees, which is great because I mean I should get 57, 57, 57, you know. So I got my theta right here of 57 degrees. Step number 9 on your lab paper says write down what is the theta for radian number 3. For me, it's 57 degrees. Now we get to the part that I like. So the next part, where are we at? Number 10. Now, on number 10 says, before you do this again, okay? We came to an area that we kind of got to pause for a moment, and we really need to, because this is the kicker. This is what just solidifies it together. We put the Jell-O in the fridge for 3 hours, and now we're about to take it out because it's about to be solidified. All right, here it is. Get your piece of string. If you were to put your string here at the edge, could I wrap it all the way? Before it hits 180, could one piece of string fit in this little section? No. Put it on your paper. What's that, number 10? Look at your lab paper. It says, if you got your piece of string, it says on your lab paper, would one piece of string fit before it hits the 180 mark? No. So write that on your lab paper. Look at number 11 on your lab paper. It says, get your piece of string, fold it in half, it says. Now, will half of it fit in that one little section? Will half of it fit? Moore says no. Cameron says no. Austin says no. Write no on your paper, number 11. No, half of it will not fit. What is half into a decimal? 0.5? So 0.5 is not going to fit. Okay, go ahead. It says on the next one, I think it's number 12. It says fold it again into 4 pieces, right? Like quarters, which would be 0.25. Would 0.25 of your string fit in this section? No. So write no again. So we're stopping right here. We're looking at, we're only looking at half of the circle. So I've got radian number 1, radian number 2, radian number 3. And then I've got this little piece right here. One string won't fit there. Half of the string, 0.5, won't fit there. A quarter of the string, which is 0.25, won't fit there. So it's, I mean, if I had to come up with a decimal, like a percentage, you know, what would you think? I mean, it's definitely smaller than 0.25. If you kind of had to give me a number, Cameron, point what? Point what do you think?
Can I just give you a fraction?
Yeah, well, no, I don't like fractions. We go with decimals in physics. Point what?
Maybe like 0.05.
0.05? Ooh, that's really tiny.
No, I'm trying to think. What's 60?
Okay, well then put it in your, do the math. What do you think? How about you, Miss Moore? What do you think? How much of your string will fit in there? I need a decimal number. Austin, can you give me a decimal number? It's not 0.25, it's less than that.
0.15.
0.15? What do you think, Aiden?
About the same.